All right, class. That was pretty weak. Now, where are you on that? Where were you there? You just like completely zoned out.
Yeah.
I did not see it. Okay, gotta feel it. Class.
Yes.
That's better. Thank you, Nat. Now, from here, we're gonna do translation first, right? So I'm gonna translate the top right here. So what does tangent turn into? Y over x. Very good. Y over x minus x over y. Very good. And all that is going to be divided by yx. Y times x, right? I could do a denominator, but it's really not going to matter. So it's going to be y times x, but it's just over 1, right? So I can put it there for now. Now, the right side of this is going to turn into, what is secant? How do I write secant? 1 over x, and if it's secant squared, it's? Very good, 1 over x squared, minus cosecant, which is going to be? 1 over y squared, very good. Over 1? Oh, no. Are you saying this over 1? No, I don't do that because cosecant is just 1 over y, right? But if it was 1 over, if there was like the sine or cosecant was on the bottom, I would have to have a fraction over fraction. Right now, it's just this. All right, which one of these is more complicated? The left side, right? So I'm going to start with the left side. So what I'm going to do here is a bit of algebra. I'm not sure if I taught it to everyone because if you were in my class last year, we did a little bit of it. Not as much as we should have. But if you weren't in my class, then you probably didn't do any of it. So what I'm going to show you guys how to do is whenever you have problems like this, a big fraction over fraction, I have a minus sign in between. What I'm going to do is I'm going to multiply everything by the common denominator. So top and bottom, I'm going to multiply by the common denominator. In this case right here, what's the common denominator going to be? It's going to be, if you look, if you don't know what it is, you just multiply them all together. So this, the denominator's x, right? Over here, denominator's y, right? Denominator's 1, denominator's 1. So multiply all of them together if you don't know how to get a common denominator. So it's going to be xy, isn't it? So when I do that, I'm going to multiply by xy divided by xy. If I have the same thing on top and bottom, if I multiply by the same thing on top bottom, I get 1, right? Now, this 1, if I multiply something by 1, I get the same value. But what I'm doing right here is I'm going to have the same value, but it's going to look different. I'm not going to change the value of it. I'm changing the way it looks. Does that make sense or nonsense? Close enough? Yeah? No? 4K. Speak now, forever hold your peace. No? Okay. So are you understanding that I need a common denominator? Okay. So I went through and looked at all 4 denominators here. We had x, y, 1, and 1. Yes?
Oh,
and,
yeah.
Yeah, and to get common, I'm multiplying them all together.
Yeah. I wasn't paying attention.
Oh, okay. Yeah.
Sorry.
So let's go ahead and do our multiplication. So now I'm going to distribute this in. So when I distribute this in, I'm going to multiply it here. So when I multiply this, remember this is multiplication over here. And on the bottom of a fraction is what? Say division.
Division.
Yeah. So if I'm multiplying by xy, but I'm dividing by x, what can happen there? What can happen? What's canceling? Just the x. So the x's will cancel there, but I still have a y times y. That gives me y squared. Very good. Now, let's keep going over here. So now it's minus, bring down the minus. Now, I'm multiplying by xy, but over here, I have y in the denominator. So what's going to happen? Y is going to cancel. Very good. So y's are going to cancel. So if the y's cancel when I distribute there, what's going to be left over? X times x, which gives me? Very good. And on the bottom, I'm going to multiply, and it's just one term here. It's y times x. So it's not like a full distribution. It's not a full distribution. It's just xy times yx. There is no minus or plus sign in between, so I don't have to like distribute it. It's just this times this. So x times x gives me x squared, y times y, y squared. Does that make sense or nonsense? No? Maybe? Possibly. Speak now, forever hold your peace. Yes, you. Are you okay? Okay, good. This is going to be so weird. So, do I call you like Ame? Ame? No. What do I call you?
By my name.
Which is?
Amy.
Oh! Okay, but it's spelled exactly like someone else that tries to go by Ame? But it's okay. Anyway, so giving her a hard time because I have to. She hasn't been here all month. Anyway, this right here, I'm gonna kind of go off to the side here. So when we do a problem and we have combined like terms, I'm going to show you this right here. So if I go 1 over 3 plus 1 over 5, to get a common denominator, I'd multiply both common denominator, right? So this is going to be times 5 over 5. This one would be times 3 over 3. Right here, it's going to be 5 over 15 plus, over here I get 3 over 15. Now, this mathematical step is the step that I just took a moment ago on my other problem that I just did in my example. Now, watch this. So this is going to be combining like terms and a common denominator. So it could say 5 plus 3 over the common denominator of 15. Yes? So what I am doing here is I'm going to take these and switch them back and forth. Because what I have on my other page in my notes, it's like this. It says 5 plus 3 over 15. So it has a common denominator of 15, but I'm going to go backwards and separate my terms. So on my example right here, I'm going to separate my terms. So by separating the numerator, I'm going to get y squared over, what's going to be on my bottom?
X squared.
Very good. Both of them together. X squared, y squared. Bring down my minus sign here. Right? Because it's minus sign in between them. And over here, I get x squared over x squared, y squared. Now, looking at each term individually, what can I do with this first term? Cancel out well, the y squareds, right? I'm going to cancel out y squareds. Yeah? Okay. What about the second term over here? What could I do? Very good. Cancel out the x squareds, like that. So if I cancel out everything in the numerator, what's left over? 1. If I, in the numerator right here, I cancel out all that, right? So this is going to turn into 1 over x squared, because x squared on the bottom, right? Don't look at me in that tone of voice. I haven't got there yet. Yeah, you should see. He's doing that Medea thing with his head. Yeah, he did like 2 snaps up. All right, go ahead. What do we do with the y squareds? I canceled out. So if I cancel the top of a fraction, what's left on top? A 1, very good. Over x squared, right? And now I'm over here, right?
Oh.
Okay, I got you.
Minus, now over here, what am I going to do?
It's gonna be y. I mean 1 over y.
Very good, 1 over y squared. But wait, is there any more?
No.
What? Wait, yes? Are they matching?
Yeah.
They're matching. So what we're doing is verifying identities. So we verified, this is the work showing that the left side is equal to the right side right here. So both of these are equal to each other. I get the same thing. Does that make sense? Are we good? Or because that was a lot quicker than my last time. We were doing this on, what were we doing on Wednesday?
Mister, how come when you distributed the X, how come you didn't do the Y too?
I did. On which one? Right here?
Yeah.
So here, let me x y y x.
It's gonna be 2 x squared.
Okay, so I'm going to show this right here. So by rewriting it, do you see that right here? This is still 1, isn't it? It's the same thing on top and bottom, right? So when I distribute, I'm distributing fractions. I multiply top times top, bottom times bottom. So before I cancel, I'm going to show you all the steps that's going to happen. So when I do this right here, I'm going to have x, y times y squared, over 1 times x. It's just x, right? Because I'll multiply here and here, right? Okay, so I got that. And now minus, I'm going to do the same thing over here. And when I do this one over here, it's going to be x times x is x squared, very good. And y on top over y on bottom.
Okay, so you just throw the Y in at the end?
And you'll see. And on the bottom, when I distribute, it's this, so it's x squared, y squared, like that, right? So that's the bottom. So now looking at the top of it right here, this is the point that I said that we're canceling, because x and x, I have an x and x on top and bottom, those cancel. And if I cancel out everything in the bottom, it's 1, isn't it? So that's why this over here just came out to be, on top, just y squared. I could have put y squared over 1, but it wasn't necessary. So, and over here, I canceled out the y's, right? Cancel out the y's, so that's why I came up with minus x squared, right? And then, does that make more sense now by what we did?
Yeah, but I see it now because I thought that you didn't distribute the Y, which you did.
Oh yeah, we did, but as we did, we canceled.
Yeah.
All right. So, anyone else? Other questions? No questions? All right, good. Make sure you like, share, and subscribe. Hit that notification button. Okay, buy stuff at my merch store. And Amy, how you doing?